Hi everyone, Searing Frost here with another Python Basics video. Today we'll be talking about classes, objects, and object-oriented programming in Python. Python is an object-oriented language with all the standard class features like inheritance, instantiation, and methods. Python defines classes in a flexible and simple way. Unlike Java or C++, all class members are public and class definitions are easily mutated at runtime. This video assumes some familiarity with object-oriented concepts, and I'll also give some examples in Java as well to illustrate Python differences. Classes are defined with the class keyword. Any named statement will be added as attributes to the class. Defining variables and functions is conventional, but any statement is allowed. Class attributes can be accessed with dot syntax. Additional attributes can be added at any time with dot syntax as well. Let's define the simplest class possible, my class. It does nothing. The pass keyword exists to say, do nothing. So let's define a more interesting class and give it two attributes. X is a string, and F is a method. We'll come back to the self parameter soon. Accessing X and F are done with dot notation. Adding the attribute Y just requires an assignment, then Y is part of the class. Python gives the programmer complete and easy access to change classes at runtime. Whether you want to be doing this a lot is another question. Objects can be created by calling a class name just like a function, with parentheses. Let's go back to my class. We can define my object, and it is an instance of my class. In Java and many other languages, you create objects with the new keyword. My object isn't very interesting, so let's see if we can do more with an init method. To perform setup on a newly created object, we can define an init method inside the class definition. Init methods are Python's equivalent to Java constructors. When a class with an init method is instantiated, the init method is automatically called with the parameters passed in. Let's define a class named initClass with two attributes, x and y, and an init method. The first parameter to the init method is self, which will refer to the instance of the object being created. Self is just a naming convention, any name is acceptable. Our init also takes three parameters, x, y, and z. We can instantiate this object by passing in the parameters for x, y, and z. The self parameter is passed in automatically. We've now created an object that has the attribute x with value 3, y with value 4, and z with value 5. We can also see that the value for x and y for init class are still 1 and 2. They haven't been changed. If we try to access the attribute z on init class, we get an error because z only belongs to the object init object. Methods are functions that are attached to object instances. Init is a special example of a method, but you can define your own methods to give more functionality to your objects. Just like init, the first parameter of a method, self, is the object instance. Here, we create a class with a single method, and we'll have it return a string and the contents of self. Then we create an instance of class with method. When we check my method on the object, we can see it is a bound method. Remember, calling the method passes in self automatically, so we don't need to pass any parameters explicitly. This call is equivalent to calling the class's method and passing in the object as a parameter. Java hides the this parameter, the object instance just like self, within constructor and method signatures. Here's a basic Java class. I've commented out the this parameter for illustrative purposes. Another difference is that Java also requires the fields to be declared in the class definition. Python fields can be added dynamically to classes and objects. Inheritance is used to create a derived class with the properties of its base or parent class. In Python, inherited classes are added to the class signature. Here, derived class inherits from base class. Class inheritance can be checked with the built-in is subclass function. Pass in the derived class and the base class. Use isInstance with an object and a class to check if an object is an instance of the class. This also checks if the class is an ancestor of the object's class. Derived classes receive all the attributes of their base class. Any attribute can be overwritten by the derived class with no restrictions. Attributes are first searched for in the derived class, and then to the basis class, and so on. Use super to explicitly call the base class. Here, we override init from base class, but still call it with the super function. Our derived object will have the attributes x and y that it passed in, and also the base attribute from base class. Python also supports multiple inheritance. In Java, a class cannot extend or inherit from more than one class, but it can implement multiple interfaces, which is a way to get similar behavior. Let's define base class A and base class B. Then we can create derived class AB with the base classes separated by commas. Multiple inheritance can have some gotchas, because there are multiple ways to search for base class attributes. Python uses a left to right, depth-first search-based algorithm to search the class hierarchy. I've linked the documentation in the video description if you want more details. Java and other languages have private fields and methods that can only be accessed from inside the class. Python, on the other hand, has no restrictions on access. If you don't want a client using a field or method, you should prefix its name with an underscore. This isn't enforced by the language, but it is a convention that most Python programmers understand. Here we create a class that has an attribute underscore x enforced by convention. And the Java equivalent is just the variable x with the private keyword in front of it. Static methods are methods that belong to the class, but not any specific object instantiation. Python uses the @static method decorator to define a static method. In Java, the equivalent is the static keyword. Static method class has the decorated method f. Notice no self parameter in the static method. When we create an object instance and check the static method, it's accessible, but we can see its type is function and not bound method like we saw before. Thanks for watching this introduction to classes and objects in Python. Python is an object-oriented language when you want, and is flexible enough to be a straightforward imperative language or even functional language. If you're moving from Java or C++, just be mindful of the dynamic nature of Python. If you've been happily using Python without classes, being aware of them is important for reading code, but continue to write Python in whatever style you prefer. Flexibility is the beauty of Python. Links to the code and my blog post on classes and objects are in the description. I'll see everyone next time.